Right, you are welcome back to Sir Lisbon tutorial platform, and in this video we are taking a look at the theorems of a circle. But take note, we will only consider two theorems in this video lesson. Now the first theorem that we are looking at states that the angles subtended at the circumference of a circle by the same arc or chord are equal. The angles subtended at the circumference of a circle by the same arc or chord are equal. So let's consider the diagram below that is shown on the screen. In this diagram, P, Q, R, S, T are points on the circumference of the circle with center O. The line PQ is a chord because it is a line segment drawn from this point P to point Q, and this point touches the circumference of the circle, so it's a chord. Now this chord subtends an angle at point R on the circumference, that is angle Z. At the same time, it subtends another angle at point S, which is angle Y, and subtends another angle at point T, which is angle X. By this theorem, we say that angle X, angle Y, and angle Z are equal. Angle X, angle Y, angle Z are equal. So geometrically, we say that angle PTQ is equal to angle PSQ and is also equal to angle PRQ. That is the first theorem. So the first theorem says that the angles subtended at the circumference of a circle by the same arc or a chord are equal. So far as these three angles are subtended by the same chord PQ at the circumference of the circle, we say these three angles are equal. So let's consider this illustration diagram. From the diagram above, we can say that angle PSQ is equal to angle PRQ. Angle PSQ is equal to angle PRQ. Why? Now, angle PSQ is located here. That is angle Y. And angle PRQ is located at the point R. That is angle X. Since angle PSQ and angle PRQ are subtended by the same chord, which is chord PQ, we say the two angles are equal. Therefore, angle Y is equal to angle X. Also, angle QPR is equal to angle QSR. Let's locate angle QPR. Angle QPR is located here at point P on the circumference. So we have angle QPR located here, which is angle F. And angle QSR is also located at the point S, that is angle H. So by this theorem, we say angle QPR is equal to angle QSR. Therefore, angle F is equal to angle H. Now, angle SRP is also equal to angle SQP. Angle SRP is also equal to angle SQP. So let's locate the various angles. Now we have angle SRP. Angle SRP is located here. We have angle SRP. Angle SRP. The angle SRP is subtended by the chord SP. It's subtended by the chord SP. And angle SQP. Angle SQP is also located here, which is subtended by the same chord SP. So by this theorem, we say that angle SRP is equal to angle SQP. Therefore, angle Z is equal to angle V. Then lastly, angle RQS is equal to angle RPS. We have angle RQS. We have angle RQS. So this is angle RQS, which is angle W. And we have angle RPS. Angle RPS is also angle G. So by this theorem, we say that angle RQS is equal to angle RPS. Therefore, angle W is equal to angle G. Let's take an example. On the screen, there is a diagram shown. In that diagram, we have point PQRS on the circle, and angle PSQ is 65 degrees. We are asked to find angle PRQ and angle PTQ. We are asked to find angle PRQ and angle PTQ, given that angle PSQ is 65 degrees. So let's solve it together. From the circle, the line PQ is a chord. The line PQ is a chord. So we have the line PQ. PQ is a chord, and PQ subtends an angle at point S, which is angle 65 degrees. Now we are asked to find angle PRQ. PRQ, that is this angle. We are asked to find this angle, angle PRQ, and angle PTQ. Now from the theorem discussed earlier, we can say that angle PRQ is equal to 65 degrees and angle PTQ is also equal to 65 degrees because those angles at the circumference, are subtended by the same chord PQ. So therefore, angle PRQ is 65 degrees and angle PTQ is 65 degrees. Example 2. In the diagram above, A, B, C, D are points on the circle. Angle ABD is 42 degrees, angle ACB is 50 degrees, and angle BDC is 38 degrees. We are asked to find angle X, Y, and N, or we are asked to find the values of S, Y, and N. So let's solve this together. Now, from the diagram, you can see that angle ADB and angle ACB are produced at the circumference by the same chord AB. So, by this theorem, we say that angle ADB is equal to angle ACB. Therefore, X is equal to 50 degrees. X is equal to 50 degrees. Right. Also, angle DCA is equal to angle DBA. By the same theorem, we say angle DCA is equal to angle DBA. Therefore, Y is equal to 42 degrees. I'll come back to the diagram and explain it better. Right. From triangle DBC, we have learned that the sum of interior angles in a triangle is 180 degrees. Is 180 degrees. Thus, 38 degrees plus y plus 50 degrees plus n will give us 180 degrees. My dear students, y is known to be 42 degrees. So we can substitute 42 degrees in place of y. So when we add 38 degrees to 42 degrees and 50 degrees, we are getting 130 degrees. So we get another equation, which is 130 degrees plus n equals 180 degrees. Now we want n. So we take the additive inverse of 130. Thus, we are subtracting 130 from the left hand side and 130 from the right hand side. So when you subtract 130 degrees from 180 degrees, we are getting n to be 50 degrees. Right. Now, let's consider Theorem 2. Theorem 2 states that the angle which a chord or an arc of a circle subtends at the center of the circle is twice the angle subtended by the same chord or arc at any point on the circumference. So let's consider the three diagrams shown on the screen. Let's consider the three diagrams shown on the screen. Dear student, in all the three circles, that is circle A, B, and C, the minor arc PQ subtends angle POQ at the center and angle PRQ at the circumference of the circle. By this theorem, we say that angle POQ is twice angle PRQ, or angle PRQ is half of angle POQ. Therefore, x is equal to 2 times angle y, or y is equal to half of angle x. Right. So, let's take an example under this theorem. From the screen, PQR are points on the circumference of the circle with center O. If angle PRQ is 62 degrees, find the value of y. Find the value of y. So let's solve it together. Let's solve it together. The angle which the arc PQ subtends at the center of the circle is twice the angle that is subtended at the circumference. So, from the diagram and by this theorem discussed, we can say that angle POQ is twice angle PRQ. Therefore, y will be equal to 2 times 62 degrees, giving us 124 degrees. Giving us 124 degrees. Right. So I have a trial question for you. Pause the video and try your hands on the question. The question says that in the diagram, PQRS are points on a circle with center O. If angle PRQ is 68 degrees, find A, angle PSQ, and B, angle POQ. So dear students, kindly pause the video and try your hands on the question shown on the screen. Thanks for watching. Kindly subscribe to the channel and be updated with the subsequent videos. Bye bye.